Okay, welcome students. In this class, we are going to discuss about the algorithm of solving linear homogeneous recurrence relations. Okay, that is what we are going to discuss about that. So we have already known about that. Am I correct? What is a recurrence relation? How to solve them? And one problem I have taken now algorithm I'm going to discuss about that since I have finished one problem, and also examples we discussed, and what is a linear homogeneous recurrence relations also we discussed. Now let me give the algorithm to solve linear recurrence relations. Okay, right. Algorithm, we know what is algorithm. Am I correct? An algorithm is nothing but a precise, concise instructions to do or to finish a task. In mathematics, instruction to solve a problem, we say is called a algorithm. We say algorithm of solving linear homogeneous recurrence relations. We know what is linear homogeneous recurrence relation. Am I correct? It is a relation where each term of the sequence is based on the previously occurring terms, one or more. Then we call it as a recurrence relation, and the power of the variable is only one, and hence we say linear. Homogeneous all should have all variables, and thus we know the meaning of linear homogeneous recurrence relations. This is exactly how we solve the what is that called differential equation in our mathematics. In our mathematics, we know what is a differential equation. Am I correct? We used to write in a quadratic form or cubic form, whatever it may be. Afterwards, we will be writing the characterization or characteristics form. From the characteristics form, it is possible to find the root of the characteristic equation. From the root, we can have different types of general solution for the roots. If both are real, one type of solution. If both are imaginary, another type of solution. If one is imaginary, another is real, another type of solutions. Like that we will have. Okay, so suitable to that, we have to find the solution, and then we are finding out the constants, the value of the constant involving in that solution style. I say solution style. That is usually we used to solve. Am I correct? And that constants can be obtained by applying the initial conditions. I was solving a linear programming a linear homogeneous recurrence relation in another video, and just recall what we have done there. Okay, so let us come here. So the first step is that from the given linear homogeneous recurrence relation, okay, we have to write a quadratic or cubical form of the given equation. We can say it's a relation or equation. So from the given equation, we must write in a quadratic form or cubic form to put into a proper differential equation. If we put like that, what we'll have, it may be a quadratic or cubic. So we will have a characteristic equation corresponding to that quadratic equation or cubic equation. We will have a quadratic or characteristic equation we'll have. So if we put in a characteristic form, then it is possible to find the factorization, and from the factorization it is possible to find the characteristic roots of the characteristic equation. We know what is characteristic. Roots means the value of the variable which satisfies this characteristic equation. It is possible. The characteristic equation can be put in factorization form. From the factorization form, it is possible to get the roots of the characteristic equation. Now, after getting the characteristic equation, whether it is quadratic, whether it is real or imaginary, or both real, both imaginary, or one real, one imaginary, we have different format for the general solution of that differential equation. General solution of that equation. Right, so we have to substitute these roots on the general solution, and the general solution consists of some constants. So without finding the values of the constants, it is impossible to find the solution of the characterize what we say the regression relation. So we have to find the value of the constants by using the initial conditions. It is the usual that if a linear or whatever it may be the difference equation we have to solve, the initial condition must be given, then only we can apply and get the values of the constants. So we can find the value of the constants by substituting the initial value, and the constants you substitute in the general solution, and that general solution gives us the solution to our recurrence relation. I mean, solution means the sequence formula an or tn, whatever it may be, which satisfies the recurrence relations. Okay, and that is what we get the solution of the given linear homogeneous recurrence relation if we substitute the constants on the general solution. Okay, so I recall what I said just before about the algorithm for solving linear homogeneous recurrence relation. This is very important 10-mark question that they may ask. First, given equation change into quadratic or cubic equation, then you will get characteristic equation. From the characteristic equation you are finding out characteristic roots. From the roots we can get the general solution. The general solution consists of constants, so substituting at the initial condition we can get the constants value, and substituting the constant value in the general equation we will get the solution for our linear homogeneous recurrence relations. Okay, so this may be asked in 5-mark questions. Write the algorithm for solving linear homogeneous recurrence relations, they may ask, so you must be get ready for that. So with that I have to come to the end of this class. In another class I will come with another problem, and definitely you have to recall all the algorithms we have studied so far. So thank you very much. Thank you.